Hey, what's up, students? Let's do the laid-back scooter handle. 5 racing snails were let loose on the ground to compare their speeds. They all started and ended at different times in terms of seconds and distances, centimeters. Here is a table with their racing data. All right, so we need to order them slowest to fastest. Okay, here we go. Here's what you're going to do. To find speed, you probably want to take the change in distance divided by the change in time. So what I'm going to do to find Alfred's speed is I'm going to find the change in his distance. How far did Alfred go in how many seconds? So that's just a subtraction problem. So if I go over here, I'm going to do 21.8 minus 4.8. That gives me 17. So he went 17 centimeters in 62 minus 12 is 50 seconds. 17 divided by 50 is pretty slow. Okay, so Alfred, you are 0.34 centimeters per second. That is pretty slow. Okay, here we go. Let's do Barney. Okay, Barney went from 5.7 to 23.6. in 4 seconds to 32 seconds. All right, let's do that really quick. I think I can do a combo move. If I do a bracket, I can do 23.6 minus 5.7, close the bracket, and then divide by another bracket, who actually does the big fraction bar for me. So then I can do 32 minus 4. Look at that. It does the whole thing for me. So if you just do the change in the distance divided by the change in the time. So you can do it as separate operations and then divide your answers, or you can do it all in one big move as long as you do it carefully. Remember doing the big fraction bar here. Make sure you do the entire subtraction and then you do the division. Doesn't say, well, we don't really need a full answer. We just need to know how far. So 0.64 we'll say. Okay, we'll save it here. We can always save it for later. 0.64 centimeters per second. We don't really need the answers. We just need to order them. So right away, I know that Alfred is slower than Barney, but we need to order all of them. So let's keep going here. Can I erase some of this noise? Because this is kind of getting in the way here. Okay, let's try this again. All right, so the next one, Carlton. Carlton went from 6 to 20.7. in 2 seconds to 34 seconds. So some of these moves you can even do with a little bit of mental math, okay? So watch this. I'm going to do bracket 20.7 minus 6. And then I'm going to divide by, let's see here, going from 2 seconds to 34 seconds is 32 seconds. So I can do a little mental math there. 0.44. Okay, Carlton went 0.44 centimeters per second. Here we go. Doc Brown. Let's erase some of that extra noise. Go away. Doc Brown went from 8.2 to 19.7, then 7 to 63. So here we go. Let's go bracket 19.7 minus 8.2. Close the bracket. Divide by 63 seconds minus 7. Enter. 0.2. Doc Brown is the slowest so far. 0.205. We'll give him the 0.1. He's already the slowest so far. We don't need to hurt his feelings anymore, do we? Here we go. Last one. I got ahead of myself. I should write down what I'm doing. Going from 1.1 to 25.5. Going from 2 to 62. I can do a little mental math here. See, 25.5 minus 1.1 is just going to be 24.4. Oops. 24.4 divided by the change in the time. The change in the time was 60 seconds. 0.41. Here we go. 0.41 centimeters a second. Okay. Per second. A second is the same thing. Okay, so we have basically all the numbers. Good thing I saved all my calculations. If any of them had the same hundreds place, then you'd have to go to the thousands place to find the difference and see who's faster or slower. So let's see here. Slowest to fastest. So we were looking for the smallest number here. The smallest number will give us the slowest snail. Sorry. On Schoology, it should be an ordering question. So for here, I'm just going to go ahead and make a list. So it looks like Doc Brown Sorry, Doc, you are the slowest snail. Okay. Next is, let's see, we have 21, then 34, and then it's going to be Alfred. I can spell Alfred right. There we go. Okay, Alfred, you are second slowest. Okay, so we got you. We got 34. Next would be 41, and it's Edward. All right, Edward, we got you. Second place, runner-up is Carlton. Good job, buddy. You did it, Carlton. And then first place, the fastest would be Barney. Good job, Barney. You were the fastest snail. You were moving at a amazing speed of 0.64 centimeters per second. All right, students. So this is kind of making you find rate of change and just kind of rapid fire doing it over and over and over again. Remember, you can find the individual differences and then do the division, or if you want to risk it all, you can do a combination of differences, but make sure you use the extended fraction bar. Make sure you use brackets. Remember, new minus old over new minus old will give you a rate of change. All right, that's all I got. We'll see you in class. Goodbye.